Statistics describing the sample and measures of position. In statistics, various measures are used to describe and summarize the characteristics of a sample. These measures are important in understanding the data's distribution, central tendency, and variability. Below is an explanation of the statistics that describe a sample, including mean, median, quartiles, and percentiles, and their applications. 1. Mean. The mean is one of the most widely used measures of central tendency. It provides the average of all data points in a sample or population. Population mean. The population mean, denoted as mu, is the average of all values in a population. It is calculated by summing all the values in the population and dividing by the total number of values in the population. Mu equals sigma xn backslash mu equals backslash frac backslash sum x n mu equals n sigma x, where sigma x backslash sum x sigma x is the sum of all observations and nnn is the population size. Sample mean. The sample mean, denoted as x backslash bar xx, is calculated in a similar way but based on a sample rather than the entire population. X equals sigma xn backslash bar x equals backslash frac backslash sum x n x equals n sigma x, where sigma x backslash sum x sigma x is the sum of all observations in the sample and nnn is the sample size. In educational management (MEM), the mean can be used to analyze average scores, such as the average student performance on a standardized test or the average level of teacher satisfaction in a school. 2. Median. The median is the middle value of a data set when the values are ordered from least to greatest. It is less sensitive to extreme values, outliers, compared to the mean. The median divides the data into two equal halves. If the number of observations is odd, the median is the middle number. If even, it is the average of the two middle values. In educational management, the median can be used to determine the midpoint of a group of test scores, such as the median grade of a class, providing a more robust measure of central tendency in the presence of outliers. 3. Quartiles. Quartiles divide the data into 4 equal parts. They are particularly useful in understanding the spread and distribution of the data. First quartile, Q1. The first quartile is the median of the lower half of the data, 25th percentile. It separates the lowest 25% of the data from the rest. Third quartile, Q3. The third quartile is the median of the upper half of the data, 75th percentile. It separates the highest 25% of the data from the rest. In educational management, quartiles can be used to categorize students based on their performance. For example, Q1 can represent the bottom 25% of students in terms of grade performance, while Q3 can represent the top 25%. 4. Percentiles. Percentiles divide the data into 100 equal parts, and they are used to understand the relative standing of a specific value within the dataset. 10th percentile, P10, the 10th percentile represents the value below which 10% of the data points fall. In educational management, this could be used to identify the performance of students at the lowest 10% of scores in a class or exam. 90th percentile, P90, the 90th percentile represents the value below which 90% of the data points fall. This could be useful for identifying the top 10% of students or evaluating high-achieving students. 5. Measures of distribution, skewness and kurtosis. Skewness refers to the asymmetry or distortion in a dataset's distribution. A skewed distribution means that one tail is longer or fatter than the other. Positive skew. The right tail is longer or fatter, indicating that the majority of the values are on the lower end. Negative skew. The left tail is longer or fatter, indicating that most of the values are on the higher end. In educational management, understanding skewness helps identify whether most students are performing at the higher or lower end of the scale. Kurtosis measures the tailedness of the distribution. It indicates whether the data are heavy-tailed, with extreme values, or light-tailed, with fewer extreme values. Leptokurtic, data with heavy tails and a sharp peak. Platykurtic, data with light tails and a flatter peak. High kurtosis could indicate that the data have outliers, which might be useful when analyzing exam scores or teacher evaluations. Application in educational management, MEM. In MEM, these statistics help administrators and educators make informed decisions. For example, the mean and median can be used to evaluate overall student performance in standardized tests, while quartiles and percentiles can help identify students who may need additional support or enrichment. Measures like skewness and kurtosis can help identify whether the data is normally distributed or if special attention is needed for outliers. These measures allow educational leaders to develop policies and practices that ensure equitable learning opportunities and better targeted interventions for students based on their performance distributions. For example, if a significant portion of students falls below the first quartile, targeted interventions can be created to improve their learning outcomes. Similarly, understanding where the majority of students fall within the performance spectrum can help allocate resources more efficiently in a school or district.